Hi Uri, so welcome to your second part of your investigation where I'm going to go through part 2 and 3. So you'll probably find I pause this at different times, read through some sections, and then I'll give you some feedback. So starting off well, which is great. Question I've just got here is where you say no solution. Why is there no solution? Can you go into a bit more detail on that one? The other thing I'm just thinking is, as I've said to lots of people, we might have spoken about this in your first video, is just here, this is very, very small. It'd be worth printing this to see how small it is, to see whether it's even legible, and if it's not, it really needs to be bigger, unfortunately. But otherwise, here your maths looks good. Again, just the no solution. So here you've just said what the point of inflection is in this case. So how did you get that? Is there working in your appendices? Are you following a pattern? I don't know whether it's fair to say that there would be a pattern if you've only done one. So maybe just think about how that you got that bit there. I like this, so how you can see all of them on one graph. I think that's really cool, and it helps to see what the differences is, so I think that's good. So here you've got all your different equations. So the manipulation of L, the analytic function, horizontal translation, yep. The horizontal asymptote. Y is equal to L, yep, thirdly. Equal to L on 3. Yep, that's cool. Proven they are simply observable properties of the search function. So this means that L value purely affects the Y coordinate. Yep, so I think that's good what you've discussed there. That's really good, well done. So now you're testing A. L and B will remain the same. So you've got some graphs. So how did you get these values here? Did you do some maths? Did you just take them straight from the graph? Maybe there needs to be some things in your appendices. If that is the case, you just need to make it clear, just because at the moment we've just got a graph. So I think it would be good to see some maths there as well. So whether the A value affects the Y coordinate of the Y-intercept, yep. And the X coordinate of the point of inflection, yep. A larger A value increases the X coordinate of the point of inflection, as well as decreases the Y coordinate of the Y-axis intercept. Yep, it could be good here to go into a bit more detail and to make it even clearer to refer back to one of these graphs as an example. So you might say in graph this one here, you can see that A is the highest value, and you can see that the X coordinate is the smallest, blah, 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 blah. Also show that the Y-intercept of the search function not necessarily defined as Y is equal to L on 3, as this was simply the case because of the consistency of the A value in the previous tests. When you say previous tests, what do you mean? Do you mean the previous section? Could that be written a little bit better there? Then you've got in tested B. Again, you might need some maths there. Okay, so we've got two sort of columns here. So in the last of these tests, the point of inflection doesn't show on the FX graph. I'm using the calculus. So point of inflection, which one? Point of inflection does not show. Is that the aqua one? Is that what you're saying? So this one here. Okay. I wonder why that doesn't show. Interesting. B value has an interesting effect on the logarithmic function. It does not affect the... So see how here in your PDF you've just lost that E there, so you have to be careful in regards to that too. It does not affect the Y-intercept, nor does it affect the horizontal asymptote. However, the B value does affect the X coordinate of the point of inflection. The larger the B value is, the smaller the X coordinate of the point of inflection will be. Again, could you potentially give an example? Affects the maximum of the first derivative. Yep, so you can include that. So inclusion of logarithmic tests. Okay, so my question to you in regards to this part is, how did you come up with these here? So obviously I think in your discussion before, we could definitely see that the Y was equal to L for the horizontal asymptote, but how did you find these? I don't feel like you discussed that clearly enough to then be able to jump straight to that scenario. The other thing you can do, and you don't have to, but you could show the maths. You know how we proved the stationary point and the inflection point for the search function. You could attempt to do the same for the logistic. Again, you don't have to, but the option is there. But yeah, I think it just needs to be a bit more discussion on how you got those sections there. I think both your discussion of the limited growth model and your limitations are quite good. I think your limitations, you've got plenty there, which is awesome. Your logistic model with your limited growth function, I think you could discuss a little bit more. I know you've got your one example here of the seals, but if you could discuss a little bit more, that would be good, but you don't necessarily have to. Just saying that if you do come up with some stuff, that might be good. Here, let's see how we're going. So successfully investigated the effect of values of A and B. I think that's good. Just might need to see a bit more maths. You have discussed your findings, but we just maybe need a little bit more discussion, especially around those sections there that I discussed. Could probably add a bit more depth to your limited growth model, but I think your limitations are good. So well done on that. Now let's go and have a look at part 3. The scenario that we modelled is finding the duration of the effect of an unknown drug. Data is compiled into an Excel spreadsheet. So drug concentration in 1 millimeter of plasma by time of ingestion. Yeah. Converted into a chart using Microsoft Excel. Beautiful. Data clearly can be represented by a surge function similar to those investigated in the first part of the investigation. Yeah. Positive constants. Below. So again, I think these graphs here are probably a little bit too small. Okay, the value of problems A and B for the sign of best fit. So okay, you got that from Desmos. A is that and B is that. Okay. Okay, so that's okay. So where you came up with this function here for the one in Excel, how did you come up with those numbers? I'd really like some discussion on how those numbers came up, because what we sort of wanted to see in part 3, and you might do it further down, which I'll go and read in a second as well, but you really want to have, I'm okay that you came up with one from Desmos, but we really want to use your skills you found in part A if you're looking at surge function. So the stationary point and the point of inflection, we know how that comes about now. Now looking at this data here, can we then create our own values for A and B to then have a model, and then we can compare them. So yeah, I suppose that's maybe what you've done here, but how did you come up with those values to then put into Excel? So a little bit more discussion is probably needed there. This is the area we found. Yep. So we've gone and found the first derivative, second derivative, gone and found the stationary point and the inflection point. The significance of the maximum is that it is the highest the concentration of the plasma will be. The maximum concentration of the drug was 8 hours in accordance to the points given by the data. According to the line of best fit, its maximum occurs after 8.045 hours. Yep. Is ported into, is that the right word? So why have you, to continue the inquiry, so why have you put it in FX graph? What's the difference? What else is it going to show us? Behavior concentration of the drug can easily be tracked. Yep. There is no information as to when effectiveness will occur. Yes, there is. Yeah. So why did you say n is called 25? Maybe you could say n is equal to 25, but why did you pick n is equal to 25? And why did you pick 10, is that micrograms per milliliter? So just a few other things that you could discuss on why those numbers were picked. I don't think that's kind of coming through clearly enough. And these graphs, I think, need to be bigger as well. Maximum of the second function is slightly high because it's stacked on top of the remainder of the first function. Yep, the drug is model. Yep. That's good. Perfect for the drug. That's good. I like that, assuming that the patient does not build resistance and that the concentration reduces at the same rate forever. Yep, so I think that's good. Yep. Okay, so I think it's good here. You got some limitations. You could probably add a little bit more, I think, seeing if you can come up with some others. But I think this is really good discussion that you've got here. I like that you're showing what would happen if you had more doses. I think the biggest thing for part 3 that you probably need to look at improving on Uri is just discussing again. So obviously you've got your one from Desmos, but we also really want to discuss how you got these values to put into Excel, or how you potentially came up with your own model using the stuff that you learned in part A. So if we have a look over here, yep, so I think we can say that we've done that, but again, we might just need to discuss again how you got your own values. You probably also need to discuss your dependent and independent variables. As I have successfully stated the values of any constants in the model with evidence to support my choices. I think that's where we just need a little bit more on that to I suppose, use, as I said, what you found in part A to come up with the values using your data. Key features of the graph, I think you've done that quite well, and I think you've done your limitations quite well as well. We'll probably discuss that further. So I noticed that we don't have a conclusion yet, and that's okay. You got your reference. I don't know what to write for the conclusion, just the conjectures. So the conclusion is summarizing your results. So you could include your conjectures for sure. You just want to summarize what you found. So we haven't done that yet either, and I think I went and put your stuff about your intro and your method in the other section. So I don't think we've got, we started an intro, yeah, but I think we discussed that we could include a little bit more, and it doesn't look like we've got the method. But great start. Uri, you should be very proud of yourself on what you've achieved there. If you've got any other questions or anything like that, of course you can ask me. But good luck with your final copy. Well done.